Hello team, today's challenge is Pascal's triangle row, where we're given a number and we need to get the specific numbers in that row, right? So not the whole triangle, just a piece. If they ask us for, as an example, the fifth row, we only need to return 14641 as an array and be done. In fact, that's our first test right there, right? So we can do this a couple ways, right? We could build out the triangle and then just slice off that nth row and return it. Feels like a lot of work, definitely a lot of looping because it becomes a bit of a matrix, right? Where we have rows and columns inside of there, right? Even though they aren't stacked as columns. Imagine the ones being a column and then 1, 2, 3, 4 being a column and so on, etc., right? So a lot of extra looping in there, whereas we can do this with a little bit of math. And that's what we're going to do today, okay? So over to the code. The first thing that I want to do is the test, okay? And that's to make sure that we get a positive integer. I don't think that they actually said positive in here. It just says given an integer. So in theory, that could be negative, but usually when we're talking about Pascal's triangle, we're talking about positive integers, okay? Which means that because n is one indexed, it's not zero indexed, which becomes important in a second here. But because it's one indexed, we can go if n is less than equal to 0, okay? And if it is, let's just return an empty array, right? That makes sense. Most examples that you find online will have exactly that code. So just a little bit of an extra test, and then we can move on, okay? So the first thing is not a const, but a let. Actually, it could be a const now that I'm thinking about it. But I'm going to set it to the name of array and make it an array with 1, right? Not one, well, I guess one item, and the item is 0 indexed with a 1, which is probably going to confuse me, but hopefully it doesn't confuse you, okay? Down here, we have a for loop, okay? Let I equal 1, right? We don't need to start at index 0 because we already have it up here. So let's start at index 1 and keep going. So right here, that I is going to be less than n and I plus plus, okay? So whatever n is, we're going to work with that because here's the magic, right? Did you notice that for row 1, there's only one item? For row 2, there's only 2 items. For row 5, there's only 5 items, and so on, etc. For row 15, there will be 15 items. And in fact, that's what they return here. If you wanted to count this, there would be 15 items there, right? So we can use that to our advantage, right? We can assume that the row is equal to the number of items in that row because of how Pascal's triangle works, okay? So down here, we set a new value like this, and we are going to do some math. Now that math is going to be based off of the previous index. So it's going to be I minus 1, okay? Space it out, make it look pretty, which means that because we're starting at 1, 1 minus 1 is 0, which means that we get that 1, okay? We always get something because we returned if it's a negative number. So always going to generate something until we hit n, which is the thing that's passed in. Brilliant, okay? What are we going to hit? Well, it's going to be a fraction, right? We multiply it by some sort of x divided by y fraction, and we just need to fill these in. And it's important to note that this is what we're doing, okay? We get this fraction and multiply it by that number, and I'm going to come back to that, okay? Because I feel like I'm over talking about it early, and I don't want to do that. But right here, okay? This x, it's not going to be an x, it's going to be n minus I. Sorry, not 1, but n minus I. If we were 0 indexed, you might see it as plus 1, okay? We are not in 0 index, so we don't need that part, okay? We just need to go n minus I, and then this y is going to be I. So right here we have a flipping fraction, okay? Where it will start off as, say, 5 over 1. And then the next one will be 4 over 2, 3 over 3, 2 over 4, all the way to I did that backwards, didn't I? So 5 over 1, 4 over 2, 3 over 3, 2 over 4, 1 over 5. Okay. I'll show an example of that in just a second here, but let's finish the actual coding because it's not much. Okay. Right here we go array.push value, and then we take that array and return it. Okay. And that does it, right? That's the whole math. Again, everything hinges on this. So let me bring up a little example. We're going to paste this in just like this. Brilliant. This is our triangle again. And the goal here is to get this question mark. What is it? Well, I can tell you that it's 4 plus 1 is 5, right? If we have the whole triangle in front of us. But what if we were just doing the row, right? So at that point, we have something like this. Again, number of rows equals number of numbers. So there are 6 numbers, but we've already done the first one, okay? So that's 6 over 0. I don't think they write it like this in mathematical notation. I can't really do that inside of the editor here, but 6 over 0 becomes 1 mathematically, okay? So if you follow that premise, then we have 5 over 1, 4 over 2, 3 over 3, 2 over 4, 1 over 5, which is what I said just a minute and a half ago, okay? Based on that, we get that 1, right? We multiply 1 times 5 is 5, divided by 1 is 5, so there's 5. We take that 5. 5 times 4 is 20, divided by 2 is 10, there's 10. 10 times 3 is 30, divided by 3 is 10, there's 10. 10 times 2 is 20, divided by 4 is 5, there's that 5. And then 5 times 1 is 5, divided by 5 is 1. Brilliant, and we're done, okay? And that works the same no matter where we are. So if we wanted to, we could do the very next row. It looks like this. So again, 7 is 1, right? And we should get 6. Well, 1 times 6 is 6, divided by 1 is 6, right? 6 times 5 is 30, divided by 2 is 15. That would be 5 plus 10 is 15, right? 15 times 4 is 60, divided by 3 is 20, right? 10 plus 10 is 20, and so on down the line, okay? So these fractions, the way that these fractions are flipping as we go along, right? They are inverting as we go along, makes the magic happen. And then all we do is multiply that fraction by the previous array item, okay? Hopefully that makes sense because the entire length of this is pretty short at 13, right? 12 lines, depending on spacing, right? So does it make sense? If it doesn't, let me know in the comments and I will try to explain it later or explain it better or get some added materials, right? I tried to read the Wikipedia article on this and all that mathematical syntax kind of made my eyes glaze over. So if it did for you too, let me know in the comments, right? But it all hinges on this idea that as we go down the line, we are flipping the fractions, right? The big number, the top number is getting smaller, the bottom number is getting bigger. That's where the magic happens, okay? Did you like this solution? Did you hate it? Did you find a different one? Again, not every solution, just hopefully one good solution, okay? And hopefully I explained it well enough that it makes a little bit of sense. Again, let me know in those comments, right? Let me know how you feel about all this in those comments. Otherwise, today this has been Pascal's triangle row, not the whole triangle, but just the row, and I will see you tomorrow.